Hello, good morning. Bob Wojewodka, Lubrizol. I'm a statistician with the group, also a background in biochemistry, and heading up our Operational Excellence Initiative in manufacturing. So that's a short snippet as far as who I am. One slide on Lubrizol. We're specialty chemical. You're all customers of us in some way, in shape and form. If you put paint on your wall, shampoo on your hair, oil in your car, etc. If you've used the hand sanitizer out here in the hallway, we have some components that go in there as well. So a very diverse product line, I guess, is the main message I want to say here. Instead of talking about the company, very diverse manufacturing line, from extrusion through polymers, through fluids, through powders. But to us, when it comes to data and analytics, understanding processes, looking at critical events or abnormal situations, universal. And I maintain that's true for all of your companies as well. With regard to Lubrizol, what we do is both batch manufacturing and continuous, semi-continuous, and the whole spectrum in between. We have a full spectrum of automation from state-of-the-art cutting edge to older technology. We've been in business 90-some years now, so we have some older equipment out there as well. We're systematically moving that to be more modernized and instrumented. We do reaction chemistry, where we build new chemicals, but we also do a lot of blend. Audio went out. Can everyone hear me in the back all right? Okay. Okay. Should I take this off? I'll continue. We have both online and offline analytics as well. But we're moving more things to be online real time because we see a lot of benefits in that. Where we do more of the offline analytics is in our designed experiments, where we're bringing new reaction chemistry, product development, and also for studying processes for root cause analysis and things like that. What we're moving more and more to is trying to put an infrastructure in place to do things online real time, to be studying processes actually as they're running, because we see a lot of benefits in that, and then feed back into the offline analytics for troubleshooting and more studies, etc. And we use an extensive amount of data analytics throughout this whole process, from chemical synthesis all the way through the shop floor. So the setting. Many of you in the audience are probably vendors or suppliers of equipment or instrumentation or process control or metering. And then some of you are probably end customers like a Lubrizol, where you're bringing these systems in and trying to manufacture product. For the vendors, I maintain all customers have some similar problems. And for the customers out there, I think you can relate to it as well as far as what the setting is in our companies. One is that we work in a very highly dynamic, fluid situation today. Operators and engineers have a daunting task running these units and processes for us. And it is day to day, as you could all imagine. Things don't just run inherently the same day to day as much as we'd like to. In fact, even if it does, when we get things lined out, we're always bringing new products in. New regulations are coming, so we're always in a constant state of process improvement, and as a result, things have to adapt quickly to that. Data. You've been even hearing the new terminology of big data. Data's been out there for a long time, and it's been big for a long time too. I'm sure those of you working in this space, I see people nodding. It's not a new topic. There's been a lot of data information. What's new now, in my opinion, are people who are coming to the realization of what do you do with it. And not only that, there's more coming. Information is coming even exponentially higher than what it is now. So if you think it's big today, wait 10 years. It's going to be bigger. So how do you deal with that? We need to avoid the undesirable operating conditions, hence the topic of this session. And operators and engineers do have that daunting task. It's manage the unit, but don't forget about profitability, time cycle, throughput, safety, product quality. It's a very daunting task that people have today. So the question that we need to ask ourselves within Lubrizol, and I think all of you need to ask yourself and the suppliers, is how can we, and that the key word is we, collaborate and work together to create an environment to help these people get their jobs done to effectively produce product for us. So, to visualize the setting now, if you agree with me, it's this. There's the engineer and operator. There's management. The big data are all of these boxes, and there's a lot of boxes. Now, each of the vendors in the room see yourself as a box, and I'm purposefully depicting it this way because you are just a box in that, a very important box, but a box. The ERP system, the control system, the automation, the laboratory, these are all independent boxes to a degree today, bringing information, and engineers and operators need to work with everything in those boxes. So they need help. But there's more to the story, and there's more coming later. So how do we deal with that? And this aspect of what's typical, what's atypical, what's a critical event, what's an abnormal situation, through the myriad of this information as far as trying to push out good product. I always say better, cheaper, faster, and safer. It's the four-legged stool. All four of those are critical to us to run the business, and critical to all of the suppliers trying to help us improve. So part of a solution is what? We need to work with all of that information, the inputs, raw material inputs coming into that process, and all of the process relationships. We need to characterize and examine what's typical and atypical, what's normal processing, what's acceptable processing. It's not what's the golden batch or the golden profile, because that's univariate. That's just saying, hey, follow this, but why? Control to this, but why? What's acceptable variability is more important. Here's the profile of acceptable variability, and if you stay within that range, you will likely have a very good product when you're done. If you deviate outside of that range, it's likely to have an issue. And every step along the way, is there an abnormal situation or a critical event that needs to be brought to my attention that we haven't typically seen that's outside of this variation that we should draw to the attention of the engineers and operators who are too busy to find it themselves because they're overwhelmed, and then quickly diagnose it to take action. How do we use some of this analytics to characterize that and develop these models to basically say what's typical and atypical? And then a lot of different terminology that we've heard along the way, a fault, an abnormal situation, a critical event. It's all the same to me. I mean, it's just synonyms for basically saying the same thing of what is acceptable, what is something that we want to avoid. How do we predict end-of-batch product quality? We can't forget about that. Now, quality could take on a lot of different forms. When I say quality, a lot of people immediately gravitate to the laboratory, the analytical QA result that's generated on your product, or some type of physical attribute if you're manufacturing something that has that. But quality goes beyond that. In my mind, it's also time cycle, economics, energy conversion costs to produce the product. Those are all forms of quality to us. So that when we look at modeling and analysis, we're not just looking at an end-of-batch quality characteristic for us like a viscosity or a specific gravity or a calcium rate. We're also looking at how much did it cost us to make that product. Because in operational realm, they could tweak the process to make it very comfortable to produce good quality, but they're also slowing down the throughput, and it's impacting negatively the economics of the manufacturing. So it's a balance between the economics, safety, and the true QA lab characteristics that work together. So when we look at models, those are the Y variables that come into it. How do we optimize? Once we have that in place, how do we use that to identify typical or atypical for diagnosing that atypical situation, the fault, the critical event, the abnormal situation? And then how do we bring insight into the operations group so our engineers and operators actually learn? Which is very important to us, is we don't want things to just be black box. Put it out there, it runs, everyone's happy. But what did our engineers learn along the way about the process that they're responsible for relative to our manufacturing? We want them to gain insight with regard to the tools and our approaches. We want them to be more valuable than just watching a panel or reacting to something that comes out of the computer. We want them to learn more about the process and the chemistry along the way. So, it kind of all wraps into the title of this session, Critical Event Detection and Management. So, what is a critical event? What is an abnormal situation? Oftentimes when I talk with people, they always relate it to safety. A critical event is you do this to avoid a safety incident. And that's very true. Our definition in Lubrizol for an abnormal situation or a critical event is anything that impacts that bottom list. It's not just safety. It's anything that we want to avoid in our manufacturing. It's anything that we want to avoid is an abnormal event that we would like to detect and avoid. Within Lubrizol, we're putting together and have systematically been building what you see on this slide from a high-level management view. It's called the Operations Management System, where we work with our ERP system, our control system, data historian, a data conduit to bring that all over into the analytics. And we also work with the vendors offering for what they have to offer within their tool set for visualization, trending, basic analysis as well. However, what's important to us is bringing it into the data analytics environment, which is a separate set of tools that the vendors don't offer. The typical type of vendors, like a LIM system, have basic functionality, control systems have basic. But when you start bringing data together across all these platforms, you need to bring it, or at least we found that we needed to bring it into an environment where we could do analysis of data regardless of where it's coming from. So it's a common data analytical platform, whether it's dealing with alarms off a control system, process variables, lab data, business data. Data is data. Data analysis is data analysis. So to give it a little bit more specifics here, and let me qualify that although I'm using vendors' names here as part of our architecture, this isn't by no way an endorsement or a testimonial. We don't do that in Lubrizol, but I felt it important to basically give a visualization of how we, at least of a company, have approached this. We work a lot with SAP as an ERP system for the business. We're standardizing on Delta V as far as the automation control system platform, controls, instrumentation, etc. OSI Pi is our data historian. I mean, many of you work with that as well. And we do a lot with Microsoft and SharePoint. The key message here is that these pieces are very important unto itself. SAP is a critical business system to us. But in the environment that I'm talking about for process improvement, abnormal situation, critical event detection, root cause analysis, designed experiments, it's a data source to us. The same with a control system. Very important for manufacturing and execution of the process safety, but in this context, it's a data source to us. Same with the historian, same with the lab, same with everything else. So how do we bridge this and bring all of this information together to bring it into the context of analytics and critical event detection? It's the data engine that we're put in place to accomplish that. We've heard a lot about KPIs, metrics this week from a lot of presentations. Very important, and that's what I'm depicting at the lower part of this slide. The analytics is completely separate than that to us. That's not data analysis to us. That's a visualization and presentation of summary statistics. The top part of this slide is where we bring it into the true data analysis environment, the study processes, look at relationships, do correlations of process conditions and how that impacts themselves, and also how it impacts throughput, time cycle, quality, and then how do we use that offline and online to really study and examine the process. Oh, and then back on that slide too, a key thing that we're doing in Lubrizol that's fundamentally changing a lot of our IT infrastructure is you don't know what the guy wants or the woman wants sitting in the chair. We refer to him as Ted internally. Ted's sitting at his computer and he has to deal with something that management wants relative to the process or do a root cause analysis. That may be different than the question that was asked 2 months ago by Ted. So here's the situation I'm in today. I need to get the following information quickly. I need to analyze it quickly so I could troubleshoot or study this process or respond to a customer. Ted cannot put in a request to IT basically saying I need the following report generated of the following context, and I need that tomorrow. IT is like, well, wait a minute. Yeah, you could submit in your request, but get in line in the queue for developing it. It's not a report, it's the data. And I don't know, or I being Ted, I don't know what I need until I need it. So what I need is an environment that I could go into and query the system to pull out what I need, when I need it, in the format that I need it, to generate my own report and go immediately to data analysis so I could study this. So it's a very different way of IT thinking about this. So it's IT, how are you creating the environment within our company to allow Ted to go out and get whatever he wants when he wants it, and you get out of the way now, if you see what I mean. And the same applies to our vendors when you think about it. How do we tap into your data easily so Ted could get at it and merge it with something else that you never even thought about because we got it in our system? So, I mean, this is like the heart of what we're trying to do in Lubrizol, to really not only do an abnormal situation analysis, but truly study and improve our processes. There's 3 types of data analysis that we do: routine, offline, and online. And like I said, we're trying to move everything more online, especially when it comes to abnormal situation. We want to detect those quickly. But there are 3 levels, and the KPIs and things like that are over at the far left. Very routine, repetitive, crunch them out once a month. The data analysis offline in between are the studies, root cause analysis, designed experiments, troubleshooting, what ifs, going back and forth, bringing more data in, taking it out, etc. Very dynamic flow. And then when models are developed, put them online. When models need updated, bring it back offline, update it, redeploy. I've used this slide a lot for different presentations over the years, but it kind of shows where we're trying to head in general, and the abnormal situation, critical event monitoring fits into this as well, of really putting data to use. I mean, you've probably seen something like a rendition of this theme in some of the other presentations. I think because folks are now realizing that data could really be exploited to study processes, and moving up this chart of really getting benefit from the information that's there for studying processes. And I purposefully color-coded these charts because I see most companies today down in that orange region, not in the green. Even up to seeing people use Power Pivot and things like that, that's still just slicing and dicing available data to summarize it differently. It's really not analyzing the process to look for relationships. We're trying to get up this ascent within Lubrizol globally for all of our processes. We cover the whole spectrum today. We also try and move things online. This is just some screenshots of some of the things that we're doing with Emerson. Again, our control system vendor. You could do it with, if you have different platforms, the concept is still the same. Of as a unit is actually running, to study it by looking at the variability. If you remember Dave's slide, take existing process data, look at it for relationships, characterize the variability, develop something, deploy it, and then benchmark your next production run against it. Not the golden batch, radically different than that, but in the context of process relationships and variability. That's what we're doing here. Also with regard to product quality, whatever that quality parameter is, whether it's a lab measurement or an economic parameter that you're predicting. It could be energy consumption, it really doesn't matter. Whatever you're modeling could then be looked at online. And if something is deviating with the model's prediction of product quality at the very start of the batch, one could potentially take action. How can you do that to start? Well, you got incoming raw material quality relative to how that was used in past batches could be used at the very beginning to start to do predictions. And then as the continuous process or batch manufacturing process continues, additional data comes in that could be brought in to the equation, so to speak, at that point, to then look at anything that's atypical and update the prediction minute by minute or whatever frequency that you want, including the detection of something that's atypical that's going on. Similarly, looking at process relationships. Got all kind of process variables out there. How are they relating to each other? And is anything happening right now that's outside that envelope of acceptable operation? And if so, flag it. Allow the engineer and operator to see it very quickly, and allow them, because they don't have time, to immediately drill into the key process variables that are contributing to that fault condition. And then allow them to take over what they're good at, is understanding the relationship to take an action. but get out of the way that proliferation of data that they're trying to manage to take them to what they need to see very quickly. Fault detection. And this is the drill down, basically. Allow the operator and engineer to focus in out of all the variables that they could be looking at, or all of the trend charts in their historian that they could be bringing up, to say, look at this, this, and this, because this is where your variation's coming from right now, and it's not in a region would like to be. Act on it. So, to start summarizing up, having this type of predictability really allows one to start looking at the process in more detail for time, capacity, quality, etc. And timely, focused, and actionable information, and I strategically kind of picked those words, timely, focused, and actionable information is very useful to management, operators, engineers, or whatever situation. Timely, focused, and actionable, then it could be put to use. If it's garbled, information overload, not in a context to really understand relationship, having all this data and information could actually hurt when you think about it, and it could lead to the wrong decisions because of the relationships in the data itself that aren't being accounted for and the variability that's there. And then what we're seeing is it really gets people thinking differently. Even when you set up a control system, in the phase report parameters or wherever you call it in your application, what data do we want to collect to not only run the unit and manufacture the product safely, but what do we need to collect to study the process when it's running? Control engineers typically haven't thought that way. It's run the process safely based upon what we're trying to do with our product manufacturing. They're not involved intimately with studying processes, and as a result, it thinks differently in terms of what do we want to capture to begin with. We don't need it to manufacture, but we need it to study the process to improve it along the way. So it does get people to really start collaborating across these lines to think a little differently. And wrap up, when I mentioned to many of the people throughout my facilities and sites saying I was invited here by IRC to talk about this topic, I said, can you give me some input that I could share with the group? Because everyone talks about benefits, justification, is this important? So I got flooded with all these inputs, and what I did was just pick a few of you to read. I kind of took a cross-section. So the first one is the plant manager of the largest facility in Lubrizol. I mean, you can read that yourself. I hate to read slides. But you could see what he's saying. He's drawing the connection between lots of data, but so what? We need to be able to act on it. And then he went on to give a very favorable comment recognizing what we're doing with that information to add value. So justification, in my opinion, at least my experience in Lubrizol, is by doing. It's by example. It's not talking about it. It's implementing it and showing people. I know when I see people coming in with projects into corporate now that they're using as part of their justification what we're doing with these tool sets to move forward, I know we're making progress. If you could relate to that. When it becomes part of someone's justification for the next project to do, they see value. Management sees value. The next item is the head of the process improvement department at Deer Park. You've already read it, but you could see his analogy. Basically, it's game changers. When you start looking at the information this way, and a lot of it's available in our plants, we start to derive improvement. Superintendent from our Painesville, Ohio facility. Process improvement, safety, value. And then comment out of our Rouen, France facility with regard to a very key point. The reason I chose this is his comment. He was a chemical engineer, they're a process engineer, deriving further insight and knowledge into our processes. Very valuable through these. So, these approaches help get that donkey's feet back down on the ground and helps to unload some of that information out of the cart and then put things into a context that's informative, actionable, concrete for basically driving improvement in our process. So thank you. I'll field questions during the Q&A.